In this video, we'll continue with our discussion of the analysis of the one-way ANOVA, and now we're going to focus on post hoc tests. Recall in our prior video that our test was significant with a p-value of 0.019, which indicated that there was a significant difference somewhere between these three groups, but we didn't know exactly where the difference existed at this point. So we were going to do post hoc tests to flush out those differences and see where in fact they are. Now, post hoc tests are conducted after the fact. They are typically only conducted or interpreted after a significant ANOVA. Okay, so we had a significant result, recall 0.019. So that effectively gives us the green light to go and dive in and try and find out where the differences lie between the groups. Okay, so post hoc tests are used to, as I just said, dive in and look for the differences between the groups. And importantly, they test each possible pair of groups. So they test two at a time. So for example, a post hoc test will test none versus low volume. And there'll be another test that tests none versus high volume. And then there'll be a final test that tests low volume versus high volume. So it does all possible pairs two at a time. The total alpha used for the set of tests is 0.05, and that's important to keep in mind. It's not 0.05 per test, but it's 0.05 in total. And we're using a test which we selected in the previous video under the post hoc button, which was called Tukey. We're going to use Tukey's test, and Tukey's test does a good job at keeping the whole set of tests at 0.05. So the post hoc tests, for Tukey's test, there's actually two tables that come out. There's the post hoc tests table, which is labeled multiple comparisons. And then there's the homogeneous subsets table, which is labeled exam scores. We'll take a look at each of these in turn. So let's start with our multiple comparisons result. Now here, the way this is organized is that we have our pairs organized from left to right. So for example, this first test is none versus low volume. And if we scroll over, we can zero in on this column. These are the p-values. So here the p-value is 0.963. And we use the same decision rule as always. If p is less than or equal to 0.05, there's a significant difference between the groups. If p is greater than 0.05, there's no significant difference. So here we can see the no music and low volume is not significantly different since this is greater than 0.05. Okay, our next result we read here diagonally. So we move down diagonally, and this compares the no volume versus high volume. And as we read over, we can see that this test is in fact significant at 0.027. So there's a significant difference between no volume and high volume. Our next result, low volume versus none. If you look at this, low volume versus none with a p of 963. You know, we've already done this. If you notice it up here, none versus low volume versus none. These two have the exact same p-values. This is the same test. And this is one of the drawbacks of the multiple comparisons table. It produces actually the same test twice for each test. And we've seen this one right here. So we're going to ignore this because it tells us the same thing. Next we have low volume versus high volume. And notice that p-value is 0.049. So that's very close, but it in fact also is significant. So there's a significant difference between the low volume and the high volume groups. Hey, and then as I move down here, high volume versus none, that test has already been done here. Notice the same p-value, 0.027, 0.027. And then high volume, low volume, we just read that one right here with a p of 0.049. So in summary, the results we have here are